Hi everyone, and welcome to our latest ICP-MS coffee conversation. In today's video, I'll be talking with Bill Spence of Teledyne CETAC Technologies about rapid sample introduction systems for ICP-MS and indeed ICP-OES. Good morning, Bill. How are you today?
Hi, Simon. Yeah, I'm very well, thanks. Yeah, I'm working from home here in South Manchester as is usual these days. Thanks a lot for inviting me to talk with you.
You're very welcome, Bill. Thanks a lot for joining me today. So let's get started with today's conversation then. Teledyne CETAC Technologies have offered autosamplers for ICP-MS and ICP-OES for many years now, but rapid sample introduction systems are a bit newer and may be unfamiliar to some users listening to this video. So Bill, autosamplers are widely used, they're reliable and they're well accepted. So what's the benefit of adding a rapid sample introduction system then?
Yeah, great question, Simon. Autosamplers are great, but one problem with them is that by themselves, they're not actually that time efficient. So with most autosamplers, there's up to about 1 meter of sample uptake tubing between the sample probe tip and the nebulizer. And this has to be cleared every time the sample is introduced before a measurement can start, and then needs to be rinsed to minimize carryover between samples. Rapid sample introduction systems are designed to increase efficiency by significantly reducing sample uptake and washout times.
I see. So how do these systems work then?
Rapid sample introduction systems are an add-on for autosamplers that consist of a valve and a high-speed pump. They work by rapidly pulling the sample onto a small loop of tubing using a high-speed vacuum pump. The valve is then switched and the sample is pushed off the loop and into the nebulizer by a carrier solution delivered by the ICP's peripump. The valve is placed close to the nebulizer, so the sample transfer and stabilization time is short. Total cycle time is much less than the sample uptake and wash time when using a standard autosampler, which enables a much higher sample throughput.
Interesting. So I can see how rapid sample analysis technology speeds up sample uptake, but how does it also reduce sample washout time then?
Well, during the analysis, the probe moves to the rinse station and the vacuum pump turns on, pulling the rinse solution through the probe line to clean it. This means that the probe line is cleaned, ready for the next sample before the sample analysis is actually complete, removing the wash time from the total analysis time completely. So effectively, the wash and sample analysis processes happen simultaneously.
Sounds a very efficient way of operating then, Bill. So what kind of time savings can this approach typically achieve then compared to standard conventional sample uptake?
Well, the uptake delay only needs to be enough to cover the loop load and injection period, which could be something like 5 to 20 seconds, depending upon the loop size and the flow rate. There's zero wash time since the wash is performed during the sample analysis. So comparing this with the standard autosampling technique, we might be talking about 40 to 120 seconds each of uptake and washout delay. So you might see a total time saving of between 30 seconds and up to 1.5 minutes per sample, which can be really substantial over the course of an analysis batch.
That's quite impressive potential time savings then, Bill. So are there any other benefits to rapid sample introduction then, aside from time savings?
Yeah, you can see on the overlay plot below how it's possible perhaps to double the sample throughput of the system when using the rapid sample introduction system. And speed also brings cost savings on consumables and maintenance. Reducing the overall runtime of the ICP by, for example, 25% or maybe even 50%, you'll also save that much in argon, other consumable gases, and electricity for powering the instrument. So this reduces the cost per sample and means that you can run more samples in a fixed time period.
I see. So if I was to summarize then, rapid sample introduction systems are useful for increasing speed and efficiency, and they also bring gas, energy, and consumables cost savings as well. Would that be correct?
Yeah, that's absolutely right, Simon.
All right. Thank you, Bill. So thanks again for the informative discussion today. If any of you watching this video would like to learn more about the products that Bill has described in his presentation today and their applications, then please do take a look at the links that are provided together with this post here in LinkedIn. So thanks again, Bill, and we'll see you again next time, hopefully.
Thanks very much, Simon. Bye-bye.